Hello everyone, today we're going to be looking at a few additional examples on factorising difficult quadratics or factorising quadratics when the x squared coefficient, i.e. the number in front of the x squared, is not equal to 1. Now on the right hand side I've got an example from a previous video where we were trying to factorise the value of 3x squared plus 11x plus 6, and we use what we called the AC method, where we multiply the value of A, which is the x squared coefficient, and C, which is the value at the end, to give you 3 times 6, which is equal to 18, and finding factors of 18 that add to make 11, so which is the value in the middle, B, or the x coefficients. Over here I've got pairs of factors of 18, 1 and 18, those add to make 19, 2 and 9, those add to make 11, 3 and 6, those add to make 9. So 2 and 9 was our combination. What we did from there is we split this 11x into the 2x and 9x. We got 3x squared plus 2x plus 9x plus 6. And then we factorize these in pairs. Taking out a factor of x from the first lot, we got x brackets 3x plus 2. And from the second side, when we took out a factor of 3, we also got 3x plus 2. Now, when you're factorizing these quadratics, you must have the same bracket on the left and on the right. If you haven't, you've made a mistake, or there's something else that needs to be done. The final step is then seeing that 3x plus 2 is now common to both. If we take out a factor of 3x plus 2, we're left with the x over here and the plus 3 over here, giving us x plus 3. So as mentioned, we're going to be looking at a few different examples today, slightly more challenging, which I think people generally make the mistakes on because they get a little bit lost. So we're going to bring it to the one on the left hand side, 3x squared plus 4x plus 1. The first thing I'm going to write over here is that A is equal to 3, B is equal to 4, and C is equal to 1. So AC is going to be 3 times 1. So AC is equal to 3. Now the only combination that multiplies to make 3 is 1 and 3. 1 and 3 adds to make 4, so we can use this method. If that value was not equal to 4, we would not be able to factorize it. It needs to make sure that it does add to that value. So I'm going to rewrite this now as 3x squared plus 1x, or just x, plus 3x plus 1. We now need to factorize out the two pairs. So we look at what common factor there is over here and what common factor is over here. On the left-hand side, 3x squared plus x, we can take out a factor of x, leaving us with 3x plus 1. Now, the reason why I said this is where some people sometimes get stumped is because when we look at 3x and 1, there's not a very obvious factor here that goes into both of them. But actually, there's one value that goes into every single value whenever you're doing factorizing, and that is the value of 1. 1 goes into 3x, and it goes into plus 1. So if we take out a factor of plus 1, we still end up with 3x plus 1. Now, we can see that this is correct because we said we must have the same value in both brackets. We have over here the 3x plus 1, and we have over here the 3x plus 1. So if we take out a factor of that 3x plus 1, from this side we're left with x, and from this side we're left with plus 1. So we follow the same process there. AC, split the middle function or the middle expression, and then factorize out in pairs. Okay, I'm going to bring it to our next example. Now, we're now going to start bringing in a few negatives, but again, we need to follow the same process to do this. First thing we did was write down what A, B, and C were. A here is equal to 6. B is equal to, well, there's not a number here, but there would be a 1, so it's minus 1. And C is equal to minus 5. That means that AC is equal to 6 times by minus 5, which is minus 30. Now, with a negative value, When you're multiplying two values together and you want it to be negative, one has to be positive and one has to be negative. So actually here we have a lot of different combinations that we can get. We're doing this, AC would be, we could say 1 and minus 30, we could say minus 1 and 30. We could say 2 and minus 15, or we could say minus 2 and 15. We could say 3 and minus 10, or minus 3 and 10, and we could also say 5 and minus 6 and minus 5 and 6. Now if we add these combinations together, there's only one that is going to add to make minus 1. 1 and minus 30 gives us minus 29. Minus 1 and 30 gives us 29. 2 and minus 15 is minus 13. Minus 2 and 15 is 13. You'll notice these pairs are always the same value when you add them. Just one is a negative version of the other. So over here, 3 and minus 10 is minus 7. Therefore, this is 7. 5 and minus 6 gives us minus 1. So this is our combination. That is how we will be splitting this. So it's going to be 6x squared plus 5x minus 6x minus 5. So we are going to be factorizing out these values in pairs. Our pair on the left-hand side over here, taking out a factor of x, gives us 6x plus 5. Now the right-hand side, again, there's not a very obvious factor that goes in, so we are going to be using the value of 1 again. However, if I use a factor of plus 1, I end up with minus 6x minus 5. But we can see that the two brackets are not the same at the moment. So there's been a problem here because this is not the same as this. So the other common factor I could have taken out was not just plus 1, it would have been minus 1. If I take out a factor of minus 1 would multiply with 6x to give minus 6x, and minus 1 times plus 5 would give us minus 5 when we expand it out. Now we can see those two common factors are the same. 6x plus 5 is the same on both sides. So I can now finally, to finish this off, take out a factor of 6x plus 5. Taking out a factor of 6x plus 5, we would be left with, on the left-hand side, x, and on the right-hand side, negative 1. Once again, that means we follow the same process. We first worked out a, c over here. We found our two factors that add to make the x coefficient of minus 1. We split it up, factorized in pairs, and then came to our final step of the final factorization. So with all this, we're going to look at one final example just to be comfortable with the process. We have this question over here, which is 4x squared minus 12x plus 9. Once again, we find the values of a and c. So a in this case is equal to 4, b in this case is equal to negative 12, c is equal to 9. So a times by c is equal to 4 times 9, which is 36. Combinations that multiply make plus 36 are 1 and 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now we'll notice that none of these combinations add to make 12. 1 and 36 is 37, 2 and 18 is 20, 3 and 12 is 15, 4 and 9 is 13, 6 and 6 is 12. So there's a bit of a problem here. However, to multiply to get a positive value, you either need to have two positive values or two negative values. So actually this could have been minus 1 and minus 36, because those also multiply to make 36. And if we add minus 1 and minus 36, we get minus 37. So actually, because this middle value is negative, these values must all be negative as well. And the only combination that multiplies to make 36 and adds to make minus 12 is minus 6 and minus 6. We subtract 6 from negative 6, you get negative 12. So that is our combination. Therefore, what this means is I can now split up my minus 12x into 4x squared minus 6x plus 9. And from this, we follow our same processes which we've done throughout this entire task. We factorize in pairs. We look at the left-hand side. This is my first pair. This is my second pair. So taking out a factor of 2x is common to both 4x and minus 6x, 4x squared. So we're left with 2x minus 3. Now again, if I want to get 2x over here, the value that will be taken out as a factor over here is 3. So if I take out a factor of 3 from here, I'm going to get minus 2x. So I need to again take out a minus from here, giving me 2x, and then minus 3 times minus 3 gives me 9. We now have the same factor over here and over here. So once again, we underline those two common factors, giving us 2x minus 3 and also 2x minus 3. Now, if I want to, I could actually write that as 2x minus 3 squared, but it doesn't matter. It's just kind of showing how else we can write this, because we are just simply multiplying 2x minus 3 by itself. So here is the full process. We followed it every single time here for this AC method. You multiply the value of A with C. You find the two values that add to make minus 12, or the x coefficient, but multiplied to make A and C. You then split up your x coefficient into those two values, factorize them in two pairs, and then finally do that last step. Now, I hope that's made sense. If it hasn't, please do let me know. Please comment below, or if you have any other examples you'd like me to go through, please write them in the comments below.